Dear students, I welcome you all to 9th standard. I hope you are safe at home, and this is the maths class for you. And today we are going to see the first chapter, number system. Number system, the mysterious world of numbers. The number system is the first chapter for you. So before entering into this, I would like to make you remember that the first chapter what we have studied in 8th standard. Do you remember? Okay. That is rational numbers. The first chapter what we have studied in 8th standard is rational numbers. So you should just recall it. Huh? Now, just recall what is natural number. So natural numbers is nothing but counting numbers, and it is denoted by the letter capital N. Starting from 1, 2, 3, like that, it goes on. So this is called natural numbers. And whole numbers, so W, capital W to denote the whole numbers. Natural numbers is from 1, 2, 3, etc. But whole numbers is from 0 up. Therefore, we can say natural numbers with 0. Natural numbers with 0. We can say whole numbers. And next, coming to integers, Z is the letter to denote integers. So, starting from negative, minus 4, minus 3, minus 2, minus 1, and then 0, 1, 2, 3, 4, etc. So this is integers. In number line, in 8th standard itself, in number line, center you put 0, and left side negative numbers, right side positive numbers. We will write like that. So this is called integers. So another way you can say 0, 1, 0, 1, 2, 3, we can say whole numbers. So whole numbers and negative numbers combined to form integers. So this is the another way of explanation. And then coming to rational numbers. That is the first chapter of 8th standard. So rational numbers. Q, letter Q is to denote rational numbers. So the rational, the word itself, the first 5 letters of the word ratio. Ratio means 2:3. We can write as 2/3. So ratio, the root word, and we get rational numbers. So decimals terminate or repeat. In decimal expansion, we can say the rational numbers, if in decimal, it will terminate or repeat in decimal part. That means non-terminate means it will repeat. Terminate means okay. That's all. So this type of numbers, rational numbers. And coming to next is irrational. So this is the new point here. So irrational, opposite to rational is irrational. So irrational numbers, we can put letter Q dash like that. Q is rational means Q dash is irrational. So which cannot be shown as ratio. Here rational numbers we can show in ratio. For example, 2/3. So we can say like 2/3. So that is rational. But irrational numbers we cannot write as 2/3, or generally we can say P/Q. So in decimal we can say decimals do not terminate. Decimals do not terminate. Do not show repeating pattern. That means non-terminate and non-repeating numbers are irrational. Examples, these are 5, √2, E. These are the higher class they will use. 5, √2. If you can have a good example. So these are combined to form rational and irrational, combined to form real numbers. You see, real numbers that stand for letter capital R. So this is the introduction of the number system. Now, after the introduction, we deeply get into the rational numbers, irrational numbers and decimal expansion of both rational and irrational. Now, the definition of rational numbers is a number which can be written in the form P by Q. P by Q. P and Q are integers. Integer by integer. P integer, Q also integer. And the condition is the denominator Q not equal to 0. So, this is the definition of rational numbers. Example, 2 by 3, integer by integer, so it is a rational number. Minus 3 by 4, so it is a rational number. Negative in the numerator and positive in the denominator. 2 by minus 7, so positive integer by negative integer. Anyhow, integer by integer, so it is a rational number. And 0 is also a rational number, that we will see later. Okay. Irrational numbers, that is opposite to rational. Which are not rational, they are irrational. So, a number which cannot be written in the form P by Q are called irrational numbers. Example, root 2, root 3, pi. So, these are examples for irrational numbers. And now, clearly we can understand by decimal expansion what is rational and what is irrational. You can clearly understand by the decimal expansion. So, when you divide 1 by 2, you get 0.5, it terminates. So, no more digits come. So, 5 by 4, the answer is 1.25. So, it also terminates. Terminate means end. So, decimal expansion, terminating decimal means a number when we divide, the decimal will terminate at certain digits. That's all. That is called terminating decimal. So, these are the two examples. And non-terminating repeating decimal. So, what are they? You see, when you divide 10 by 3, when you do that 10 by 3, you get 3.3333, it goes on, so on, it goes same way. That after the decimal point, you get the same thing. So, it can be write in short 3.3 bar. The bar represents that digit is repeating 3.3333, etc. And another example, 14 by 11. The answer is 1.272727. When you divide 14 by 11, you get 1.272727. That means what? After the point, two set of digits are repeating. So, etc. In short, you can write this as 1.27 bar. That bar represents here, under that bar, two digits are there. So, it means two digits are repeating. So, 1.272727. So, that means what? Non-terminating but repeating. The another word for repeating can use recurring. Okay. So, the above two forms are rational numbers. First, decimal expansions represent rational number. Terminating decimal also rational number. Non-terminating repeating also rational number. And now coming to the next, that is irrational form. Non-terminating and non-repeating decimals are irrational numbers. For example, you take root 2. If you find the value of root 2, you know, you studied in 8th standard itself in the chapter squares and square roots. Do you remember? I hope that. Okay. So, root 2 is equal to 1.41421356, etc. That means what? It goes never end. It goes on and never end. So, it is not repeating also. Different digits are coming here. So, root 2 is irrational. You see all the other root 3, root 5, the same way. The value 1.732 is the root 3 value, and the next is again 0, 5, 0, 8, 1. It is not repeating, not terminating, not repeating. And root 5, you take the value is 2.23606798, and it goes on. So, it is also non-terminating, non-repeating. And you take the value of pi, 3.14159265, etc. So, this is also example for non-terminating and non-repeating. So, this is irrational numbers. And now coming to the exercise 1.1. The first question is 0 a rational number? Can you write it in the form P by Q, where P, Q integers and Q not equal to 0. That's the condition for rational numbers. So you can write 0 as 0 by 5 or 0 by minus 3 or equal to 0. So generally you can say 0 by any non-zero integer. The denominator should not be 0. So I am writing here any non-zero integer. So 0 we can represent integer by integer form. So 0 you can represent by P by Q form. Therefore 0 is a rational number. Now coming to question number 2. Find 6 rational numbers between 3 and 4. So how many they are asking? 6 rational numbers they are asking. So you take that 6 plus 1 is what? 7. And now in the solution, first number is 3. Just you multiply 3 into 7 by 7. That means numerator and denominator. You multiply and dividing by the same number. Then you get 21 by 7. And the next number 4. 4 into 7 by 7. We are multiplying 7 and dividing by 7. Or multiply 7 by 7. Like that. Now you get 28 by 7. So this is the way. Shall I repeat it? They are asking 6 rational numbers. So 6 plus 1 is what? 7. So that we keep in mind. And the first number you have to multiply and divide by 7. You get 21 by 7, which is nothing but 3. And 4, again you multiply 7 and divide by 7. That is nothing but 28 by 7, which is equal to 4. And now you easily write the numbers between these two. What are they? Therefore, 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7 are the 6 rational numbers. 6 rational numbers between 3 and 4. So you can write like this. And we can collect the numbers between these two. That keeping the denominator 7 in all the numbers, you can easily pick out 22 by 7, 23 by 7 and so on 27 by 7. So these are the 6 rational numbers between the given two numbers 3 and 4. And now coming to the question 3. The solution part. I am writing. The first one we are asking is 5 rational numbers. 5 rational numbers between 3 by 5 and 4 by 5. So this is the question. We have to find 5 rational numbers between 3 by 5 and 4 by 5. So solution. 3 by 5. How many rational numbers? 5. So multiply by 6. You get 18 by 30. And the next number 4 by 5. You multiply by 6 and divide by 6. You get 24 by 30. Now easily you can collect 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30 are the 5 rational numbers between 3 3 by 5 and 4 by 5. So this is the solution. Can you understand? Okay students, now listen. Exercise 1.1. The fourth sum is true or false. Okay, the statements will be given and you have to say whether the given statement is true or false. Every natural number is a whole number. Every natural number. Do you know what is natural number? What is that? Natural number means 1, 2, 3, etc. Counting numbers. Whereas whole number means 0, 1, 2, 3, etc. Therefore, by comparing this, what I have written, by comparing this, can you say true or false? Because natural number is 1, 2, 3. So whole number is also 1, 2, 3 is there. So every natural number will be whole number. So it is answer what? True. Can you understand? Okay. And every integer is a whole number. So what is integer? Z is the integer, you know. So etc. minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. So this is integer, you know. And what is whole number? 0, 1, 2, 3, etc. So comparing these two, can you say, is it true or not the given statement? Every integer is a whole number. So integer negative numbers are there. Whereas in whole number only positive. So the answer is what? False. And coming to the third option, every rational number is a whole number. So, how to say every rational number means what? Rational number Q. In this Q, integer will come, all the whole numbers and natural numbers, everything will come in this. So, of the form P by Q also what? Integer by integer. That's also rational number. But in whole number, only the W. That is already I have written. You see here 0, 1, 2, 3, etc. That is only whole number. So every rational is a whole number is wrong. Okay. So answer is false. And now coming to the exercise 1.2. First question. 3 options given in a statement. Here also we have to say each statement is true or false. Every irrational number is a real number. Every irrational number. I already, while teaching the topic, I explained clearly. Real number means the combination of real number. Capital R stands for real number. That is the combination of Q, rational number, and Q dash, that is irrational number. These two, rational and irrational, combine to form real number. So here every irrational is a real number, correct? So answer is true. And here, now coming to the second question. Every point on the number line is of the form root m, square root of m. But inside the root m is there. M is a natural number, it is given in the question. So, no negative number is a square root of a natural number. No negative number is a square root of natural number. For example, root 4, you get 2. Don't say minus 2 because m is a natural number. Natural number means what? Only positive number. If you take square root of a positive number, you should not put the negative value for the square root. Okay? So here minus 2 you should not put because m is natural, positive number. Natural number means what? Only positive number, 1, 2, 3, etc. Positive number only. So if you take square root for a positive number, that is natural number, the answer should be in positive. But in number line means there are negative number also. In a number line, negative number is also there. So, any point, every point, that means what? Any point. Any point means negative number will also come. But here, when we take square root for a natural number, we won't get the negative as an answer. So, false. Answer is false. Okay? It's clear? It's clear to you? Every real number is an irrational. The answer is what? I think you know very well. Answer is false. Because every real number means both rational and irrational combined to form real number. So every real number may be rational or irrational. But in the question they given is an irrational. So it is false. And now coming to the question number 2. Are the square roots of all positive integers irrational? So positive integer means 1, 2, 3, etc. That is nothing but natural number. That is the positive integer. So if you take square root of 1, you get 1. It is what? Rational. Square root of 2, 1.414, etc. Therefore, it is irrational. Square root of 9, 3. It is rational. So, square roots of all positive integers. All positive integers means 1, 2, 3, etc. All the positive integers. Irrational, it is given in the question. You have to say yes or no. Here, rational. Here, irrational. Here, rational. Therefore, no. Answer is no. Answer is no. Not all the positive integers, if you take square root, won't come irrational. Only such numbers, root 2, root 3, root 5, alone, if you take square root, we get irrational. For these numbers and for root 9 and all, we won't get irrational. So, this statement, you have to say no. And now coming to the locate. In your book, it is given, the next question is, locate root 5. Root 5 on the number line. So, before trying to understand root 5 to locate our number line, we recall what we have studied in 8th standard. Locate 3 by 5, a rational number, 3 by 5 on number line. So, how to locate this? For this, you have to draw a number line. And from 0, it is positive number. So, from 0, you can start. 0, 1, 2, 0 by 5, 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5, 6 by 5, like that. We find the value. 0 by 5, 1 by 5, like that is graduate. With equal parts. That is 1 centimeter gap, 1 centimeter measure. We can note all the points. And now 0 by 6 is what? 0. And after that 5 by 5 is what? 1. So before 0 and between 0 and 1, we have made 5 equal parts. And the question is locate 3 by 5. Where it is? Here. So let it be A. So this point A on this number line represent 3 by 5. So this is the way to locate the given rational number. So this is you already studied 8th standard. But now we will move to the 9th standard, that is locating the square root of your number, positive number. Okay. So now locate root 2 on number line. So before that we locate a rational number 3 by 5 like that. But now root 2. So how to do this? Listen carefully. Very easy only, but you have to focus here. So just you draw a number line. And this point you mark it as O, and you take this point as A. Okay, this is 1 unit. You take 1 unit as 2 centimeter measure. So what I am telling 1 unit as 2 centimeter, then only we can get some the large gap. Okay, if you take such 1 centimeter means it will be too small to see. So to visit it clearly, you have to take 1 unit as 2 centimeter. Okay, and now OA 1 centimeter. Sorry, 1 unit. 1 unit. 1 unit is 2 centimeter measure. Just it. And from here, you draw a perpendicular. You draw a perpendicular to this line, and 1 unit you have to mark. So this also, you take it as B, 1 unit, and you join OB. Now you see OA 1 unit. 1 unit how much measure? 2 centimeter. So 1 unit. At A, draw a perpendicular. You can use either compass method by a drawing arc, or using protractor you can draw 90 degree. And AB, you have to mark 1 unit by taking radius 1 unit, and you draw arc and you mark it B, and join OB. And now OB also 1 unit in right triangle OAB. OB square, I think you know what I am doing, right? What theorem I am applying here. OA square plus AB square. This is by Pythagoras. Yes, Pythagoras theorem. By applying Pythagoras theorem in this right triangle, we can take OB square is equal to OA square plus AB square. What is OA square? 1 square, because both are 1 unit. 1 square you get 1 plus 1, 2. Therefore, OB equal to root 2 units. So this is the way to locate root 2 on the number line. Okay. So now we got OB is root 2. Now you write this is root 2. And keeping compass pointer at O and radius OB, you draw arc. Okay? Draw arc. And it will meet here on the number line. Let it be P. This point as P. Now this is root 2. Where OB and this. So OB, OP. OB equal to OP. Both are equal. That is root 2 units. So on this number line, this point P is the location of root 2. And now coming to locate root 3 on number line, the same way you have to proceed. But one more step we have to do. So the same one. You take the number line L and write it as O. Take 1 unit as A, OA. 1 unit. And we proceed the same thing. Take perpendicular. Take perpendicular. This also 1 unit. And you join. This is B. And now again, keeping OB as horizontal, you draw another perpendicular at B. From here, you draw another perpendicular. So like this, you can draw. Okay? And you take the same 1 unit measure here. 1 unit. Okay? And you join this 2 lines. You can join this. let it be C. Now you take, this is the perpendicular, so in right triangle OBC we can take OC square is equal to, so this is what, root 2. So OC square equal to OB square plus BC square. Okay, you know already from this diagram, this is root 2, OB is root 2. And again, you apply, this is root 2 whole square plus 1 square, and this becomes 2, this becomes 1, and you get 3. Therefore, OC equal to root 3 units. But geometrically, we got that OC is root 3, and you put this is root 3. And we have to locate on this number line. So, we take the compass pointer and keeping O as center, OC as radius, you draw on. Like that it will come, and mark this point as P. Now this is root 3, location of root 3 on this number 9. So OC is equal to OP, that is equal to root 3. Is it clear, children? Okay. You just repeatedly you see this, definitely you come to know what is that. You come to clear. Okay. And now in the question, in the exercise, root 5 is there. So how root 5 can be represented on number line. Okay, now you see root 5. And now in this exercise 1.2, the question number is 3. The third question, locate root 5 on number line. So before root 5, I taught you how to locate root 2 and also root 3. Now coming to root 5. So take this number line and you take this as 1 point and this as another point. This is A. Okay. This is 1 unit, this is 1 unit, totally 2 units. So OA 2 units. 2 units means 1 unit, before sum 1 unit we take 2 centimeter. Therefore for 2 units means 4 centimeter you have to take. Is it clear? And now through A to draw a perpendicular. Yeah. And just you mark it as B. This is 1 unit. How much? 1 unit. Always here 1 unit only. But here I am taking 2 unit. Why, sir? Because 2 square plus 1 square is 4 plus 1 equal to 5. Yes, sir? So 5 is what? Root 5 the whole square. So now you got the Pythagoras. Yes or no? As per Pythagoras, 2 square plus 1 square, we get 5. And 5 you can write as root 5 the whole square, which is nothing but 5. So like that, here OA 2 units and AB you take 1 unit and you join this OB, you join. And my Pythagoras in, this is I. So in right triangle OAB, okay, OB square is equal to OA square plus AB square. So this is nothing but 2 square plus 1 square. This becomes 4, this becomes 1, and when you add you get 5. So therefore OB equal to root 5. OB square 5. Therefore OB is root 5. This is how you are writing this equation by Pythagoras. Okay. This is by Pythagoras. So every sum we are writing this. And now you got OB root 5. So this is called root 5. So for root 5 you have to take from here OA as 2 units and this is 1 unit. Then we get 2 square plus 1 square, that is 5. So after taking square root we get root 5. Clear? So this is the way of locating, finding root 5. How to locate it? The same way, keeping the compass pointer at O and OB as radius to draw an arc. Okay? So like that it will come. And this point we take as P. And now OB equal to OP equal to root 5. So now the point P is on the number line. So we located root 5 on the number line. Okay. Now the last question, fourth question, you see what is given? A classroom activity is given. So it's an activity. Okay. And now what is the question? You have to construct a square root spiral. Square root spiral. So this is nothing but how we constructed locating a point of root 2, root 3, root 5. This is the subject question. Okay. If they are asking a 2 mark to locate root 5, you have to follow this method. And root 2, root 3, I taught you already. You follow that. But this is the activity. Okay. This is different from the question. So this is an activity only. So how to construct the square root spiral? So I will teach you, and you do this activity in a A4 sheet, and you bring it. Okay. Now, how to construct a square root spiral? You will figure out. First, you draw a number line and mark a point O here, and take OA is 1 unit distance. Okay. So OA equal to 1 unit. I already told you 1 unit we take as 2 centimeter measure. Then only it will be easily visible. So don't be confused. So it will be visible clear. So OA you take 1 unit and 2A you take that is 1 unit. It is a perpendicular and you join this. So let it be B. So this is perpendicular. We have to draw a perpendicular to A and AB also 1 unit. Clear? This is 1 unit and this is AB also 1 unit. And this is root 2. Already I told you. And then from here, if you draw a perpendicular, from here you draw 1 unit distance perpendicular, 1 unit distance, and you join these two. Here, and let it be C, and this is also a perpendicular 1 unit distance you have to take. All these are 1 unit only. Is it clear? All these results are 1 unit only. So then this will be this root 2 and this is 1. If you apply the Pythagoras, you get OC as root 3. Is it clear? And again at C, you take a perpendicular. Clear? Perpendicular to this OC. Okay. So you have to take this. Okay. So this is also how much unit? 1 unit distance. And you join this. Okay. So this you have to join. Okay. It's not clear. So the measurement I am doing now. Roughly I am doing here. So you take the scale properly with the ruler and you go it. Okay. You see how it's coming? So this is OP and this is the perpendicular. Always here 1 unit only. So draw a perpendicular to OC, that is CD, and get 1 unit. Now this OD will be root 4. Root 4. Clearly I am writing. So this is root 4. Root 2, root 3, root 4. And again, if you proceed in the same way, you can get root 5. So how? You have to draw a perpendicular here. Okay. Again, 1 unit distance. Draw a perpendicular. You have to join here. You have to join here, and it will be E. Now you get this root 5. What? Root 2, root 3, root 4, root 5. Now OE, you get root 5. You look, it comes like a square root spiral. Okay, in this way, every time if you draw a perpendicular to the horizontal, OD perpendicular is D. Like that, if you proceed in this way, you get a spiral like this. Okay, so this is called the construction of the spiral. Clear? So you do this as a homework in an A4 sheet. You take that 1 unit measure as 2 centimeter and you proceed how I taught now. So root 2 and then root 2, root 3 and then root 4 and then root 5. So root 4, you know, that is 2. Here also, this is 1 unit. If this is 2 unit means it will be x. So here also another 1 unit. So this is what? 2. That is 2 units. Therefore, when 4 comes, if you take OD as radius and O as center, if you draw, it definitely it will touch here. So from OX will be you get 2 units. Definitely it will touch. It will come clear. If you do correctly, accordingly, definitely you will get correct answer. Thank you, children. You practice, keep on practice.